Hi all. Today we're taking a look at Arithmetic Sequences Day 2, and I believe we're going to call this Assignment 74, but I'm not entirely sure about that yet. Arithmetic Day 2. And today we're actually going to talk about series. And as I mentioned in the last video, a series is the sum of a sequence. Okay, so we're going to be focused on the sum of arithmetic sequences today. But before we get to that, I just want a little reminder of some of the things we're supposed to know how to do. Find a sub 300 given a sub 6 equals 27 and a sub 11 equals 52. Please find a sub 300. Okay, why don't you pause the video and take a moment to figure this out. And when you come back, I'll walk through it and you can compare your answer. So we know that arithmetic looks a lot like linear. We know that the common difference is the same as m. So I'm going to think about these as ordered pairs, 6, 27, and 11, 52. And I'm going to use those to find slope. M equals 52 minus 27 over 11 minus 6. Okay, so I want to say 25 over 5, or 5 is my d value. And so I'm going to use one of these pairs, and my d value in a sub n equals a sub 1 plus n minus 1 times d. So here's n, here's a sub n, and here's d. 27 equals a sub 1 plus 6 minus 1 times 5. So we've got 27 equals a sub 1 plus 25, or a sub 1 equals 2. Now that I know what a sub 1 and d are, I can plug those values back in to this model and get a sub n equals 2 plus n minus 1 times 5. And if I tidy that up, that would be 5n minus 3. So if I want to know a sub 300, I just replace n with 300, and I get 1497. Okay, so there's our first bell work problem. Let's do one more of those, just to get you warmed up. Find a sub 400 given a sub 4 equals negative 4 and a sub 9 equals negative 19. Again, I don't have a sub 1 or d, but that doesn't stop me from saying negative 19 minus a minus 4 over 9 minus 4. So I get negative 15 over 5, or negative 3 for my d value. And then I use d in one of these ordered pairs in a sub n equals a sub 1 plus n minus 1 times d. So negative 4 equals a sub 1 plus 4 minus 1 is 3 times negative 3. So there's negative 9. If I add 9 to both sides, I get 5 equals a sub 1. So then I can write this model, 5 plus n minus 1 times negative 3, which would be negative 3n plus 8. There's a sub n, and therefore a sub 400 is going to be negative 3 times 400 plus 8, which is negative 1200 plus 8, or negative 1192. All right, so there we go. I also want to introduce a new notation today. we know that a sub 400 means the value of the 400th term, or the term value when n equals 400. But I want to look today at s sub 400, and that's going to be the sum of the first 400 terms in the sequence. So instead of just finding the first 400 terms, we want to now find them and add them all up. That's what we're going to be focused on today. And there are a number of ways of doing this. One involves sigma notations, which we're not going to get to, but another involves Carl Friedrich Gauss. And there's a long-told story, perhaps myth, perhaps true, that when Gauss was a small boy at school, he was being disruptive in class, and his teacher was really sort of tired of him misbehaving. So his teacher said, "Okay, Carl Friedrich, I want you to add up all the numbers from 1 to 100." And Gauss was a little sad about this, a little confused, but he was a good kid. He said, "All right," and he sat down at his desk and he started thinking, and he thought, well, 1 plus 2 plus 3 plus 4, and he kind of got tired. So he said, well, what if I start with 100 plus 99 plus 98 plus 97, and he got tired. But then he noticed something, that if he added these pairs, he got 101 plus 101 plus 101 plus 101 plus, and so on. And he thought, well, every pair is adding up to 101. I wonder how many pairs I have. So 100 divided by 2 said he had 50 pairs of 101. So he did 50 times 101, and he came up with 50-50. And he brought this to his teacher just not much longer than it took me to write this up. His teacher is very upset. His teacher thought that he'd given Gauss something to do all day long to keep him out of his hair. But no, Gauss had figured this out, that he could add up pairs. And we can use that same approach today with this formula, where we take the sum of n things, and this is for arithmetic. There's a different formula for geometric, and there's different formulas for polynomials. So for arithmetic sequence, the sum of n things will be n over 2. That's how many terms you have divided by 2. This figures out how many pairs, times a sub 1 plus a sub n. This is the value of the first term. This is the value of the nth term. So if I start with a really basic sequence like 3, 7, 11, 15, and I want to talk about the sum of those terms, the sum of those 4 terms, then I'm going to say 4 divided by 2, a sub 1 is 3, and a sub n, that's the value of our 4th term, is 15. So we end up with 2 times 18, or 36. Well, let's test this out. 3 plus 7 is 10, plus 11 is 21, plus 15 is 36. So yeah, no problem. This method is going to work for us. So let's see how we'd be using this in our problems. So I've got a sub 1 equals 40, d equals negative 3, n equals 30. And I'm looking for the s sub 30. I'm looking for the sum of the first 30 terms in the sequence that starts with 40 and goes down by 3. 40, 37, 34, 31, etc. But we want a sum. We want to add these values together for the first 30 terms. So if I want to use this formula, n over 2 a sub 1 plus a sub n, I need 3 pieces of information. I need to know how many term numbers there are. Well, we were given that. I need to know a sub 1. Ooh, we were given that. We need to know the value of a sub 30. Okay, so how are we going to find that? Well, we remember that a sub 30 is a sub 1 plus 30 minus 1 times negative 3. We know a sub 1 is 40, and so we can say 40 plus, this is 29 times negative 3, 60, 70, 87. So negative 47 is a sub 30. Well, great. Now we know what that is. We can plug that value in here. So negative 47. So now we've got 15 times negative 7. 105. Negative 105 is the sum of the first 30 terms. No, I'm not actually going to go and add those up. You can, though. So I needed to use what we learned in our last lesson about writing the model for an arithmetic sequence to find a sub 30. I needed to find the value of the 30th term in order to find s sub 30. So let's practice some more of that. Second problem, a sub 1 equals 5, d equals 3, and n equals 40. Okay, so if I'm looking for the sum of the first 40 terms, I want 40 over 2. I want a sub 1 plus a sub 40. But I don't know a sub 40. So I'm going to have to find a sub 40. I know that a sub n equals a sub 1 plus n minus 1 times d. And we can plug in our values for a sub 1, for n, and for d to find a sub 40. 5 plus 40 minus 1 times 3. Okay, so that's going to be 122, I believe. Let's just check. 39 times 3 plus 5, yes, 122. So now we're going to plug this in here, and we're going to have s sub 40 equals 20, 5 plus 122, which is 20 times 127. 20 times 127 is 2540. Okay, so it's not so bad, but it does require me to be comfortable with this part. I really can't find the sum of these 40 without knowing the value of the 40th term. All right, how about in this situation? What can we do here? 2, 8, 14, 20, and I want to know s sub 40. Well, I see a sub 1 is 2. And I see that these are all going up by 6 each time, so I know that d is 6. And I know that I'm looking for the value of the 40th term. So I'm also going to need to find a sub 40. So a sub 40 will be a sub 1 plus n minus 1 times d, where n is 40. Well, we know our d value is 6, and we know a sub 1 is 2. So 240 minus 6 is 234 plus 2, 236. I'm just going to check that because I'd hate to get this wrong. 39 times 6 because I was rushing too much plus 2, 236. Good. So now we have our a sub 40, our d, and our a sub 1. We can find s sub 40 by saying s sub 40 will be 40 over 2, a sub 1 plus a sub 40. So that's going to be 20 times 238, and 20 times 238 is going to be 4760. Okay, how about this one? 40, 37, 34, 31, and so on, and I want s sub 30. Okay, why don't you pause the video and give this one a try. Come back when you're done. We're looking s sub 30 in this arithmetic sequence. Welcome back. I see a sub 1 is 40. That was given to me. I see these are going down by 3 each time, so I know that d is negative 3. And if I'm looking for the sum of the first 30 terms, I'm going to do 30 over 2, a sub 1 plus a sub 30. Well, I know a sub 1, but I don't know a sub 30. So I have to find a sub 30. A sub 30 equals a sub 1 plus n minus 1 times d when n equals 30. We know that d is negative 3. And we know that a sub 1 is 40. So I get 40 plus 29 times negative 3. That's negative 78 plus 40, which is negative 38. I believe, let's just check, 29 times negative 3 plus 40. No, it isn't. It's negative 47. And that's why it's good to check our work. All right, negative 47 is a sub 30. So we're going to take this a sub 30 value and plug it in here. We're going to get negative 47 plus 40 is negative 7. And we get 15 times negative 7, which is negative 105 s sub 30. 15 times 7. Yes. All right, that's the sum of the first 30 terms. Now, you might be saying, well, these are all positive. Why isn't this number positive? Well, we keep subtracting 3, and by the time we're all done, our last term is negative 47. And so we've got more negative numbers than we do positive numbers, and the result of adding up all these positive and negative numbers is going to be this negative number. Okay, how about this one? What if I tell you that the sequence is 3 plus 7 plus, I'm sorry, the series is plus, and I keep going until I get to 75. And I want to find the sum of that series. Well, I don't know how many terms that is. N equals what? Well, here's what I do know. I do know that a sub 1 equals 3. And I do know that these are going up by 4, and so I know that d equals 4. Can I build the rule? Well, let's see. We know that a sub n equals a sub 1 plus n minus 1 times d. So we know that a sub n equals 3 plus n minus 1 times 4. Or 4n minus 1 is a sub n. So this is the rule that generates these values. And I'm wondering what n value it takes to get 75. So let's put a 75 here for the value of the term. And let's solve for n by adding 1. 76 equals 4n, and dividing by 4, and I get n equals 76 divided by 4, 19. So I'm looking for the sum of the first 19 terms. We know the value of a sub 19 is 75. That's good. And I think we know everything that we need to know in order to find S sub 19. It's 19 over 2, 3 plus 75. That's a sub 1. That's a sub 19. Now, don't do that. Just do 78, this. So we've got 19 times 39. Well, 19 times 39, and I get 741. So the sum of the first 19 terms, the sum of this entire sequence, is going to be 741. Okay, so let's see if you can do one of those. 17 plus 12 plus 7 plus 2, and so on until we get to negative 38. Okay, I want the sum of this arithmetic sequence. So, press pause, give it a try. All right, welcome back. I see here that a sub 1 is 17, and I see these are not going up by 5, but down by 5, so I know d is negative 5. I use this information to build the rule a sub n equals a sub 1 plus n minus 1 times d, 17 plus n minus 1 times negative 5, which gives me negative 5n is 22. So this is the rule that generates these terms. When I plug in a 1, I get 17. When I plug in a 2, I get 12. Well, I want to generate negative 38. What term number do I have to plug in to get negative 38? So let's plug in a value of negative 38 and solve for n. We'll subtract 22. We get negative 60 equals negative 5n. And when we divide by negative 5, we get n equals 12. All right, n equals 12, and we know a sub n is negative 38. We have enough information to use Gauss's little formula. S sub 12 would be 12 over 2, a sub 1 plus a sub 12. So that's going to be 6 times negative 21, which is negative 126, the sum of the first 12. All right, let's do one more of those because I'm not quite convinced yet that you're comfortable with it. 2 plus 9 plus 16 plus and so on until we get to 282. Please find the sum of this series. Why don't you pause the video and give it a try? Welcome back. I see that a sub 1 is 2, and I see that this went up by 7, and this went up by 7, so I know that d is 7. So I build my model. A sub n equals a sub 1 plus n minus 1 times d. It's going to be 2 plus n minus 1 times 7, or 7n minus 5 for a sub n. We want to know when this rule takes on this value, 282 is 7n minus 5, so we can solve for n, the number of terms. That's what we don't know that we need in order to use Gauss's formula. So I'll add 5 to both sides. I'll have 287 equals 7n, or n equals 41. So I know that n is 41 terms, and now I'm looking for the sum of these 41 terms. Well, let's use Gauss's formula. he said, remember, S sub n equals n over 2 a sub 1 plus a sub n. In our problem, we're looking for the sum of 41 things. So we have a sub 1 plus a sub 41. Well, we know that a sub 1 is 2. There's a sub 1. And a sub 41 is this last term here, 282. And so I end up with 41. 284 divided by 2 is 142. And so I want 142 times 41. Okay. Times 41. And that gives me 5,822 is the sum of the first 41 terms. Excellent. The last problem I want to look at with you today is a word problem. I don't know if any of you have had a chance to go to the beautiful Fox Theater downtown, but there are lots of seats. And a nice thing about going to an old restored theater is seeing just how beautiful they've made the interior. Well, they had to redo all those seats. And one of the things that we'll need to do is count. Count how many seats there are. So let's try this. Let's say that there are 10 rows, and the first row, the one closest to the stage, has 17 seats, and then the next one, row 2, has 23 seats, and then the third row has 28 seats. But after that, you get kind of tired of counting, and you wonder if there's a faster way. Well, sure there is. In this case, we notice that these are going up by, I seem to have a typo here. If this goes up by 6 and this goes up by 6, this must be 29. Let's try that again. Okay, so I've got a D value of 6 and an A sub 1 of 17. What information do I need to find S sub 10? Well, 10 over 2 A sub 1 plus A sub 10. Ooh, I need the value of the 10th term. How can I find that? Well, I can write the arithmetic rule for this sequence, A sub 1 plus n minus 1 times d, and I can plug in what I know. I know that A sub 1 is 17. I know that n equals 10, and I know that d equals 6. So this is 9 times 6, 54 plus 17, which is 71. So we know that A sub 10 is 71. And now I think we have enough information to figure out how many seats there are in these 10 rows. We'll put a 17 in here for A sub 1, and we'll put a 71 here for A sub 10. So what do we get? We get 5 times 88. Isn't that 440? 5 times 88. Yes, 440 seats total. Okay, so I'd like you to do a similar problem, but this time there are more rows. There are 20 rows, and this time there are fewer seats as we go away from the stage. The theater goes like this, and there are fewer and fewer seats as we head to the back. So 20 rows. The first row has 40 seats, the second row has 37, the third row has 34 seats, and this continues. So I'd like to know the sum of those 20 rows. Well, I know that S sub n equals n. Well, wait, maybe you should try this. Why don't you pause the video and you give it a try? Okay. Welcome back. So we know that S sub n is n over 2 A sub 1 plus A sub n. And in this problem, we know that n is 20 because we want the sum of 20 rows. We know there are 40 seats in the first row, but how many seats are there in the 20th row? I don't know that yet. So I'm going to have to use my prior knowledge to figure that out. A sub n equals a sub 1 plus n minus 1 times d. A sub 1 is 40 plus n minus 1 times our d value. This is going down by 3, this is going down by 3, so our d is negative 3. So I get negative 3n plus 43 is a sub n. And I want to know a sub 20, which means I'm supposed to put a 20 in here. Mr. Kukla, that's not possible. You can't have negative seats. Wah, wah. Well, I'm going to finish off the problem anyway, but I'm definitely going to change this to be 30 rows for next time. Okay. A sub... No, I don't want that. Oh, sorry. Not 30 rows. 20 was too many. How about 15 rows? Okay. If I plug a 15 there, and I need a sub 15, and I plug... Oh no, 15 is too much. 14 rows. 14 rows. 14. A sub 14. Aha! That's negative 42 or positive 1. Yay! A sub 14 rows. Okay, so there are 14 rows. There's one seat in the 14th row. So let's find the sum then. A sub 1 was 40, and a sub 14 was 1. So I have 7 times 41, or 287 seats total. All right, thank you with patience on that while I went and checked my work. How about we do one more? The sum of 20 rows, if the first row has 42 seats, the second row has 46, and the third row has 50. Please find the sum of the seats in this theater with 20 rows, where there's 42 seats in the first row, 46 in the second row, and 50 in the third. All right, why don't you hit pause? Welcome back. I see my a sub 1 is 42, and I can tell pretty quickly that d is plus 4. But I don't know a sub 20. So I'm going to have to find that first. I know a sub n equals a sub 1 plus n minus 1 times d, or 42 plus 20 minus 1 times 4, which is 42 plus 19 times 4. Well, 19 times 2 is 38, and 38 times 2 is 76, plus 42 is 118, is a sub 20. So then S sub 20 will be 20 over 2. A sub 1 is 42. A sub 20 is 118 seats across. Very big theater. We've got 160 times 10, or 1,600 seats. All right, well, so that's the sum of arithmetic sequences. In the next videos, we'll be looking at geometric sequence and then the sum of a geometric sequence or a geometric series in our last video. Hope you have a great day, everyone.